Ever get the feeling that someone is watching you? Paranoia? Probably. But in 1985, you could never be sure. That opening line,
Yeah.
it's just so perfect. It's got this this chilling, almost film noir vibe to it.
It really does.
And it sets the stage for a world that, most of us today just don't even have to think about. We live with security protocols like SSL, HTTPS. They're just there.
They're invisible. And they're free.
Exactly. It's all just running in the background, a basic part of how the internet works. But if you rewind the clock 4 decades, back to 85, this is long before the World Wide Web.
Oh, yeah.
The only way you were moving sensitive digital files was, connecting 2 computers over a public phone line with these screechy modems.
And that reliance on a public network, on, just standard copper wires, it created this very real anxiety, this fear of eavesdropping. People knew those lines weren't private.
So today, that's what we're doing. We're taking a deep dive into the January 1985 issue of Personal Computer World magazine. Specifically, a review of a software package called Datatalk.
A fantastic name.
Isn't it? And our mission is really to understand how these early micro-users, these pioneers, how they protected their digital secrets. And maybe more importantly, what did sophisticated encryption actually mean when you bought it on a single, fragile 5.25-inch floppy disk?
It's a great question, because what you're seeing here is this collision. You've got the brand new digital world crashing into the old political anxiety.
The Cold War paranoia.
Precisely. That line from the review, you could never be sure. That taps directly into the whole atmosphere of espionage, of surveillance. These were ideas that were everywhere in the culture, and suddenly they weren't just in spy novels, they were on your desk, in your computer.
And up until this point, real security, proper cryptographic defense, that was for governments, right? Or the military.
Right. It was for the big institutional players, huge corporations running mainframes, governments, the military. They were using these specialized, incredibly expensive hardware solutions.
How expensive were we talking?
Tens of thousands of pounds, easily. So what Datatalk represents is really the democratization of encryption. It's taking this powerful security, which the review says was literally beyond the means of the average micro user, and it's putting it into a software package.
Affordable one.
While affordable is relative, it was still pricey, we'll get to that, but it meant a small business owner, a doctor, an enthusiast. They could finally buy what the review called peace of mind. They could bring real high-stakes security into their personal computing world for the first time.
Okay, so let's dig into that. Let's start with the threat itself. Why did this product even need to exist? The reviewer, Peter Bright, he points out that as more people started using modems,
The fear just grew with it. Yeah, people were dialing into bulletin boards, into corporate networks.
it wasn't just like the government listening in, was it? That wasn't the main driver.
No, not at all. The real driver was economic. It was industrial espionage over the phone lines. Think about it. If you're sending, I don't know, new product designs or financial forecasts between 2 offices, that data is just flying naked over a public phone line. Anyone could, in theory, tap that line.
So stealing your competitor's data becomes a real and probably pretty low-risk business strategy.
A very real one, and that very specific high-stakes context, that's what explains the product's origin story. This wasn't some hobbyist in a garage.
Right. The company was called Datasoft, based in Ilminster, Somerset, so not exactly Silicon Valley.
Not at all. A small regional firm. And they didn't develop this for gamers or home users. They originally built Datatalk as a high-security communications package for a very specific client.
Which was?
The medical profession.
Okay, that changes things. That immediately raises the stakes. We're not talking about business secrets anymore.
We're talking about patient records. Deeply personal, protected information. And you have to remember, even in the 80s, before all the formal privacy regulations we have now, there was a massive ethical and professional duty to maintain patient confidentiality. So for Datasoft, the goal was simple. Make sure no one, no hacker, no competitor, no one could read patient records being sent between, say, a clinic and a pharmacy.
So the encryption couldn't be an add-on. It had to be the absolute core of the product from day one.
Exactly. It was foundational. It had to be robust and non-negotiable. And that's really the key difference between Datatalk and maybe a simpler, faster comms program from that time.
So let's talk about the product itself. You buy this, you get it home. It's made by Datasoft, as you said, but it was distributed by Thorn EMI.
And that's a big deal.
A huge name. That gives it instant credibility.
It shows they saw a real business market for this. This wasn't just a niche product. Thorne EMI thought this was essential for the future of business computing.
And it ran on the IBM PC and its compatibles, of course, the dominant platform. It all came on one 5.25-inch disk.
And the specific version we're talking about, the heavy-duty one with the encryption, its power was all packed into one single file.
Datacode.exe.
And we have to just pause on the size of that file. The review says it took up very nearly 100K.
Which sounds like nothing today. My phone takes photos bigger than that.
It's nothing now. But in 1985, your whole IBM PC might only have 256K, maybe 512K of RAM. Your floppy disk could only hold 360K total.
So 100K is a massive slice of the pie.
It's a huge commitment of your system's resources. And that tells you something important. It tells you the encryption algorithms weren't simple, they were complex, they were resource intensive. It proves the security part wasn't just marketing fluff, it was the main event. The size proves that you were paying a premium for some serious chunky code.
Okay, so we understand the existential dread and the technical footprint, but what was it actually like to use? You sit down at your desk, you fire this thing up. What do you see?
Well, the interface was actually pretty modern for the time. It used a hierarchy of menus, and the reviewer immediately compared it to the one program everyone knew.
Lotus 123.
Exactly. And in 1985, that's basically the highest compliment you can pay a piece of software. It meant it was professional, it was logical, you'd move a highlight bar, hit return, or if you knew your way around, you could just type the first letter of a command.
And the escape key was your get-out-of-jail-free card.
Your universal back button, yeah. It felt efficient, which is exactly what their business and medical clients would have wanted.
But it wasn't just all business, was it? It had a little bit of flair and some very 80s quirks.
Oh, it absolutely did. Let's start with the flair. The splash screen, when you loaded it, you got the copyright, the serial number, and your own name.
The owner's name right there on the screen.
And the reviewer just loved this. He called it a great ego boost, seeing your name in lights.
That is brilliant. It makes you feel like you're in charge of this powerful, personalized system. It's not just some generic utility. It's security as a status symbol.
It totally is. And you needed that little ego boost because it helped you get past some of the program's visual problems that were really rooted in the hardware of the time.
Okay, like what?
Well, the main editor window, it was small, only 75 characters by 13 lines, and it used reverse video, so bright white text on black blocks.
Okay, I can picture that.
The reviewer said it looks pretty, but that all of that white on the screen made the monitor flicker more than usual, which was very distracting.
Wait, why would more white cause more flickering?
It's a classic issue with old CRT monitors. To make those big, bright white blocks, the monitor's electron gun has to work really hard, exciting a lot of phosphors very quickly. And if the refresh rate of the monitor wasn't perfect or the graphics card was struggling, you'd see this constant, subtle, and very distracting shimmer.
Wow. So it's a perfect example of this cool design idea running headfirst into the physical limits of the technology.
Exactly that. You get the ego boost of your name, followed immediately by a headache from the flickering screen. A very 80s trade-off.
And the problems didn't stop with the flicker.
No. The reviewer also said that if you opened up multiple windows, which the program let you do, the whole screen just got very cluttered and confusing. Windowing was new and exciting, but without the high-resolution screens we have today, it often just meant visual chaos.
So to help the user navigate all this, the program really relied on the function keys. F1, for example, was for help.
But not just any help. It was context-sensitive help.
Which was a huge deal back then.
Revolutionary. The idea that the program knew what you were trying to do and gave you help for that specific command, that was amazing. It meant you didn't have to keep a giant, thick manual open on your desk all the time.
You could also customize the function keys, right, to automate things.
You could, yeah. You could assign strings up to 40 characters long, but there was a catch. The main function keys, F1 to F10, they were already reserved for system commands.
So you could only customize the shifted ones. Like Shift F1, Shift F2.
Exactly. But that was still incredibly useful. Think about logging into a remote system like Telecom Gold. It was this tedious sequence of typing your account number, then a password, waiting for prompts.
The real pain.
A total pain. With Datatalk, you could program that entire sequence into a single Shift F key. You press one button combo and it does the whole dance for you. That's a massive productivity boost.
So the built-in help was great. What about the actual printed manual that came in the box?
Wow, the manual. Well, it looked the part. It was a professionally presented typeset 30-page booklet. But it was badly written, confusing, probably rushed. It's a classic story in software, even today. great-looking box, professional manual, but the content just isn't there.
So the software was basically saving itself from its own bad documentation.
It was. That brilliant F1 help system was so good that the reviewer said he rarely had to refer to the flawed manual. And that really shows a turning point in software design, doesn't it? The program itself was becoming the teacher.
Okay, let's get into the real nuts and bolts. The communication features. The setup menu was your command center for getting the modem to work.
Right. This is where you'd fiddle with the baud rate, word length, stop bits, parity,
Right.
all that technical stuff you had to get exactly right or nothing would connect.
And the review copy had a really interesting and slightly dangerous feature here. It let you use split baud rates.
It did. So you could set it to, say, receive data at 1200 baud, which was fast for the time,
Right.
but only send data back at a very slow 75 baud.
Why would you want to do that?
It was for services like Prestel, where you were mostly just downloading pages of information and only sending back tiny little commands like a single key press. It optimized the flow, but the reviewer was very cautious about this.
Why? What was the risk?
The risk was that the hardware in the IBM PC, the communications chip, wasn't really built for that. It struggled to handle two different speeds at the same time in what's called full duplex mode.
Meaning sending and receiving simultaneously.
Exactly. If you tried to send something, even slowly, while a huge stream of fast data was coming in, the chip could get overwhelmed. You'd get what's called a buffer overflow.
And you'd lose data.
You'd lose data. Chunks of the incoming file would just be gone, corrupted. So the reviewer's advice was basically, don't touch this feature. It tells you a lot about the priorities back then. Data integrity was everything. You'd always choose reliability over a little bit of extra speed.
Which makes perfect sense if you're sending patient records. That brings us to file transfer protocols. How did Datatalk make sure the files actually arrived in one piece?
For general use, it supported the industry standard, which was the X-modem protocol.
Everyone used X-modem.
Pretty much, because it had error checking. It would send a block of data, calculate a checksum, and the receiving computer would have to confirm it was correct before the next block was sent. And crucially, it could handle binary files.
So not just text, but actual programs. .com files, .exe files.
Right, essential if you're distributing software securely. But if you were connecting to another computer that was also running Datatalk, you had a better option.
A proprietary protocol.
The proprietary one, yeah. The Datatalk protocol. And its big advantage was that it could handle wildcards. So instead of sending 5 different files one by one, you could just type .com and it would send them all in one go.
A huge time saver.
A major efficiency gain, for sure.
Now, one of the most unusual things about this program was that it had a built-in text editor. Why bother with that when everyone had a proper word processor like WordStar?
It was all about workflow. It was a utility for when you were live, connected to another system. The editor itself was, basic.
Yeah.
It ran in that flickering reverse video and was pretty limited.
But the reviewer found one part of it extremely annoying.
Oh, yes. The flashing message. If you opened the editor and it was empty, it would just flash text editor is empty at you. Over and over again.
That sounds awful.
Imagine trying to compose a serious, confidential message with this giant banner blinking at you constantly. It's a perfect example of how little user experience was sometimes considered back then.
But despite the flashing and the fact that it was super basic, no block deletes or anything, it had one massive advantage.
A game-changing advantage. You could pop into the editor by pressing F8 while you were still logged in to the remote system.
So you didn't have to log out, open your word processor, write the reply, save it, close it, and then log back in again.
You skip that whole painful dance, and if you've ever had to use the horrible line editors on old services like Telecom Gold.
They were terrible. You could only edit one line at a time.
Exactly. So being able to quickly write a polished reply locally in an editor you knew and then paste it in, that was a huge quality of life improvement.
And what happened if the other computer sent you data while you were typing in your local editor?
This is where the software was really smart. It would just buffer it. It would collect all the incoming data in the background without interrupting you. Then, when you went back to the main terminal screen, poof, it would all appear. It was very clever design. It meant you never lost a connection or missed important incoming information.
Okay, let's get to the main event, the encryption engine. This is what you were paying the big bucks for.
This is the heart of the whole thing, yeah. The actual algorithms were a company secret. They relied on what we'd now call security through obscurity.
So we don't know exactly how it worked?
We don't, but they did reveal the basic technique. It was a 2-key shifting substitution method. which means it was much more complex than a simple kid's cipher. It required two separate, very different components to work.
Okay, let's break that down. Component 1 was the encryption table.
Right, this is like the master code book. To
Right.
create one, you'd go into the menu, select generate, and then you'd have to type in a table creation key.
Which could be pretty long.
Up to 40 characters. And once you entered that key, the computer would just churn. The reviewer said it would think for a while.
How long is a while?
On an IBM PC, it could be up to 3 minutes. 3 minutes of the computer just maxing out its processor, running through these secret algorithms to generate this massive substitution map.
And the file it created was always the exact same size.
Always. 10,241 bytes. No more, no less.
That's such a specific number.
It is. It suggests a really fixed mathematical structure. This wasn't random. It was a precisely engineered digital artifact. This 10K file was your complex, unique dictionary for scrambling your data.
And there were 2 types of tables you could make.
Yeah, you had text mode, which was the less secure one. It only worked with standard ASCII characters for when you were connecting to a really old or limited system.
But the real one was data mode.
Right. Data mode could handle everything, the full 256 character set, including the binary data you'd need for .exe files. That was the one you'd use for any series security.
Okay, so that's the table. Component 1, what was component 2?
Component 2 was the encryption key. This is another secret phrase. Again, up to 40 characters long. But this one was different. This one was critical.
How so?
Because unlike the 10,241 byte table, which you saved to your disk, the encryption key was never, ever stored on disk. It was volatile. It only existed in your head.
So if you forgot it,
You were done. The data was gone forever. To decrypt a file, you needed both the exact same table file and the exact same key you used to encrypt it.
and the program wouldn't warn you if you got it wrong.
No warning,
What?
no incorrect password message. You'd pick the wrong table or type the wrong key, the program would run, and the output file would just be gibberish, as the reviewer put it, just scrambled noise.
That's brutal. It puts all the responsibility on the user.
All of it. Now, this is where it gets really, really interesting. Despite all this complexity, Datasoft made a very specific and I think very telling claim about their security.
What was that?
They claimed the encrypted file was unconditionally secure,
Okay.
as long as the file isn't any longer than 10K.
Wait, what? Only 10 kilobytes. That's tiny, even for 1985.
It's stunning, isn't it? A 10K limit for what they call unconditional security. In modern crypto, that phrase means something very specific. It means it's theoretically impossible to break, even with infinite computing power.
So why the size limit? If their math was so good, what difference does the length of the file make?
It speaks directly to the potential weaknesses in their method. With these kinds of ciphers, the biggest danger is repetition. If the pattern you're using to scramble the data starts to repeat itself, a cryptanalyst can spot that pattern and use it to break the code.
And a longer file means more chance of the pattern repeating.
Exactly. Datasoft was essentially admitting, our system is really, really complex, but if your message is longer than about 10K, the patterns might start to become visible to a really determined attacker. It's this incredible moment of honesty about the technological limits of the day.
So below 10K, you're safe. Above 10K, you're gambling.
That's a great way to put it. And yet, the actual process was pretty fast. The reviewer encrypted a 20K file, so double their safe limit, and it only took 23 seconds.
That's not bad at all for an old IBM PC.
It's very respectable. It shows the time-consuming part was the initial 3-minute table generation. The day-to-day encrypting and decrypting was actually quite quick.
Okay, now we have to talk about maybe the most bizarre part of this whole thing. A security feature that wasn't a feature at all, it was a bug.
Yes. The illegal file name bug. This is just peak 1980s computing.
So the program let you save a file with a name that the operating system, DOS, shouldn't have allowed.
That's right. You could name a file FRED with a space in the middle. Standard DOS would never let you do that. The space was an illegal character in a file name.
So Datatalk was basically corrupting the file system.
In a way, yes. It was writing an entry to the disk directory that the basic operating system commands couldn't understand. So if you were at the C prompt and typed dir, you might not even see the file. If you tried to copy it or delete it using DOS, you'd just get a file not found error.
But Datatalk could still find it and open it.
Because it knew its own secret. It had its own way of reading the disk that bypassed the standard DOS commands.
So the reviewer, Peter Bright, He didn't see this as a terrifying bug that could corrupt his whole disk.
Far from it. He loved it. He said he wasn't annoyed by it at all because, and this is a direct quote, "No one else could read nor delete my files."
That's amazing. Security through chaos.
It really is. It shows that for many users, the primary threat wasn't some sophisticated spy tapping the phone lines. It was your coworker or your kid snooping around your floppy disks. This bug became a feature, a perfect, simple way to hide your files in plain sight.
That whole mindset is just, it's so alien to how we think about computer security today. I mean, let's tie all this functionality back to the cost. The software was selling this idea of peace of mind. How much did that piece cost?
It was a very serious investment. The standard unencrypted version of Datatalk was 135 talks, which was already a lot.
But for the full package, with a datacode.exe file?
The full encrypted version was 225 plus VAT. So the encryption part alone cost you an extra £90.
We need to put that 225 figure in context. What is that in today's money?
If you adjust for inflation in the UK, 225s in 1985 is roughly £750 in 2025.
750 pounds.
£750. Think about what you can buy for that today. A decent laptop, a high-end graphics card for your PC. It was a major, major purchase.
What else could that money have bought you back in 1985 for your office?
Oh, it could have bought you a top-of-the-line dot matrix printer. Or another floppy disk drive, which would have been a huge upgrade. You were making a real choice. Do I buy more utility and productivity, or do I buy security?
The fact that people, especially in the medical field, were willing to spend that kind of money on a piece of software tells you just how real that anxiety about eavesdropping was.
It tells you everything. It was a real and present danger in their minds, and this was one of the only accessible solutions.
So what was the final verdict? Was it worth it? The price, the flickering screen, the weird bugs?
The reviewer's conclusion was really balanced. He said that as a simple communications program, Datatalk was just average. It was fine, nothing special. But the addition of the encryption algorithms that pushed it a level above its competitors. In the end, all the little quirks, the screen clutter, the bad manual, the flashing text, all of that was outweighed by the sheer usefulness of the package for its one true purpose: protecting secrets. Is the best option you had.
It really was a product of its time.
Absolutely. And this deep dive, it just gives us such a clear window into that world. If we were to, sum up the key nuggets for you, the listener.
Let's do it.
First, I think, is just that idea of the democratization of encryption. We saw how this vital technology moved from being this unbelievably expensive mainframe hardware thing into a piece of software that a small business or a doctor's office could actually buy.
Driven by that real-world need to protect patient records.
Exactly. Second, we got to look inside the black box. We saw that two-key structure, that huge 10,241 byte generated table combined with the secret 40-character key that you had to remember. Lose either one and your data was just gibberish.
Then there was the bug that became a feature.
The paradox of security. The FRED bug, how this flaw in the system was embraced by users as a great privacy tool because it hid their files from the basic operating system. Just incredible.
And finally, that limitation.
That amazing 10K file size limitation for unconditional security. It's such a perfect symbol of the cryptographic constraints of the 1980s, that constant battle against repeating patterns in your ciphers.
It's fascinating to look back at a time when digital privacy wasn't a given. It was a luxury add-on that cost the equivalent of 750 pounds.
Right.
And today, we get robust encryption for free in our web browsers thanks to things like Let's Encrypt. Datatalk is this powerful reminder that while the tech has become infinitely more complex and cheaper, the core anxiety that drives it all is exactly the same as anyone else listening on the line.
And maybe a final thought to leave you with, connecting that past to our present, we saw that it was the medical profession with its need to protect patient data that drove this early innovation.
Right.
So think about today. What are the modern high-value industries? Maybe it's the giant data sets that power AI or the biometric data streaming from all our IoT devices. What are they doing to drive the next revolutionary and probably very expensive leap in encryption? And maybe ask yourself if that old model, the secret algorithm that Datasoft relied on, can that idea even survive today in a world where we demand open source code and constant peer review to trust our security? Something to chew on as you log off your current, very secure session.